Okay, so we're looking at situation 2 for the dance, and we have a DJ who's going to play music. The DJ charges $20 per hour plus a $50 appearance fee. Represent the relationship between the number of hours the DJ works and the total cost. Okay, so right there, that gives us the last two things that I underlined, gives us our titles for our table. So I have number of hours, and I have total cost. Okay, and we are going to use the first piece of information that I underlined to get our process going. Okay, and when we think about a dance, when we're thinking about what we want to put in our table for number of hours worked, when you think of a dance, dances typically are only a few hours long, so we don't want to skip count or anything like that, because most dances are about like 3 or 4 hours, so we really don't need to have a whole lot of data. Okay, so I'm just going to count by ones on my for my number of hours. Okay, so let's assume that we work 0, that the DJ works 0 hours, but he comes. He still comes, but he hasn't worked any hours. Okay, we're not going to be charging that $20 per hour. However, he still charges the appearance fee. Okay, so without working any hours, just to get the DJ there, the total cost is $50. Okay, if he works 1 hour, he's going to charge $20 for that hour, plus the $50 appearance fee, which gives us $70 for the total cost. For 2 hours, he would charge $40 plus the appearance fee, giving us a total of $90. Okay, and you can see our process, so I'm just going to continue the process for 3, 4, and 5 hours. And now we've got this lovely table that we need to graph. Okay, so I'm going to start by drawing my axes like I did in the examples yesterday. So because all of my values are positive numbers, I'm just going to stay in the first quadrant. So I'm just going to show this one portion of the graph because we don't need to know anything about the negative numbers. Okay. All right. We need to do some labeling here. So I know that my x-axis is representing the number of hours. And I know that my y-axis is representing the total cost. Okay. All right, so looking at my x-axis and how I want to label them, I want to kind of spread this out a little bit. So I'm just going to count like every other grid line is going to be 1. So that's going to be 1, 2, 3. Because I want to spread my graph out a little bit so it's not smushed. Okay. All right, and then keeping in mind that at the origin is always 0. And then I want to look at my total cost. So I need to fit from 0 all the way up to 150. So looking at this, I'm probably going to have to count by tens. Okay, so I'm not going to label every grid line. I'm just going to label every other one. But we are going to count by tens so I can fit everything here. And then that allows me to get all of my data from my table on my actual graph. Okay, so let's start plotting some points here. So I have 0 hours costing $50, which is going to be right between 40 and 60. 1 hour is going to cost 70. 2 hours is going to cost 90. 3 is going to cost 110. 4 is going to cost $130, 5 is going to cost $150, and I can even fit one more. 6 is going to cost $170. Okay, so there's my graph. Right, and then the last thing that we need to do, we need to write the rule. So let's look at the table. Whenever we're writing the rule, we need to find a certain number of things. So first let me write down our skeleton equation here. Okay, that's what we're going to fill in. And we're going to fill that in by analyzing our graph. So let's take a look. So I have from 50 to 70 to 90 to 110 to 130 to 150. Those numbers are getting bigger, so I know I'm adding. What am I adding? I'm adding 20, and that's true all the way down. So I'm going to go over and look at my change in x now. My change in x, I'm just counting by 1, so I'm adding 1 all the way down. So when I go to find my slope, we know that the slope is the change in y divided by the change in x, which in our case is 20 divided by 1, giving us 20 as our slope. So I'm going to fill that in my rule. And then we also need to go back and find the y-intercept. Remember, the y-intercept is the y value when x is equal to 0. So my y-intercept is 50. Always a good idea when we're writing the rule to define our variables again, just so we know. So x is the number of hours, and y is the total cost, because that's going to help us answer some questions that we're going to be asked next. Okay, so we are being asked, how much will the DJ charge for playing 3 hours? And also, how much will the DJ charge for playing only 2 hours? And then we're going to choose which representation we used and why. Okay, so let's take a look. I know if the DJ plays 3 hours, then the total cost is 110. Okay, so 3 hours costs $110. Okay, and I use the table because 3 hours was in the table. Right, what about for 2 hours? So I'm actually going to use a different representation this time. So I'm going to actually look at the graph for 2 hours just to show a different representation. Okay, and I can see that 2 hours cost $90. And I'm going to say I use the graph because the point 2, 90 is there. Okay. All right. Next one. The committee has a budgeted maximum of $130. How many hours of DJ services will that amount provide? All right, so there's a couple of different things. You could find 130 on the table, which, you know, $130 is right here on the table. You could even find it on the graph, $130, and trace it down to find out how many hours. I'm going to show using the rule, just so that we have an example where we use the rule. Okay, so if we are looking at $130, $130 is a total cost, so that's going to go in for y. So plug for y. Okay, so I'm going to use my rule, 130 in for y equals 20x plus 50. and I'm going to solve. Okay, I'm going to solve using my inverse operations. So I'm going to start by subtracting 50 from both sides. And that's going to give me 80 equals 20x. And then I'm going to get rid of this 20 by dividing both sides by 20. So that tells me that x equals 4. So we know 4 hours is the answer. And what representation did I use? I used the rule because I could substitute 130 in for y. Okay, all right. So that's a good, you know, we looked at all 3 different representations here. So, yeah, so that should give you a little bit more practice. Homework tonight, you're going to be doing the same thing as your